In continuation to the previous topic, today we will study the effect of moving a force and the equivalent force couple system. When a number of forces and couple moments are acting on a body, it is easier to understand their overall effect on the body if they are combined into a single force and couple moments having the same external effect. The two force and couple system are called equivalent systems, since they have the same external effect on the body. Moving a force from A to B when both points are on a vector's line of action does not change the external effect. Hence, a force vector is called a sliding vector. But the internal effect of the force on the body does depends on where the force is applied. When a force is moved but not along its line of action, there is a change in its external effect. Essentially, moving a force from point A to B, as shown here, requires creating an additional couple moment. So moving a force means you have to add a new couple. Since this new couple moment is a free vector, it can be applied at any point on the body. When several forces and couple moments act on a body, you can move each force and its associated coupled moment to a common point O. Now you can add all the forces and couple moments together and find one resultant force couple moments pair. If the force system lies in the XY plane, such as in a 2D case, then the reduced equivalent system can be obtained using the following three scalar equations. If resultant force and resultant moments are perpendicular to each other, then the system can be reduced further to a single force Fr by simply moving the resultant force from point O to P. In three special cases, concurrent, coplanar, and parallel systems of forces, the system can always be reduced to a single force. Considering this example, a 2D force system with the geometry is given, and we need to find the equivalent resultant force and couple moments acting at A, and then the equivalent single force location measured from A. So first we will sum up all the X and Y components of the force to find the resultant force. Then we will find and sum all the components resulting from moving each force component to A. And then finally, we will shift the resultant force to a distance d using this equation. So summing up all the force components in the x direction, the resultant force in the x direction is 60 pounds. The resultant force in the y direction is 180 pounds. And the resultant moment in the clockwise direction is minus 640 pounds-feet. The resultant force magnitude is 190 pounds and the angle is 71.6 degrees with x-axis. The equivalent single force Fr can be located at a distance d measured from A using this equation, and it is 3.56 feet. In this second example, the slab is subjected to three parallel forces. We're going to find the equivalent resultant force and couple moments at the origin O. Also need to find the location x, y of the single equivalent resultant force. Again, we will first find the resultant force, then resultant moments, and finally the location of the equivalent resultant force using these equations. So the resultant force is here minus 800 kN. And the resultant moment is minus 3600 I plus 1700 J newtons meter. The location of the single equivalent resultant force is given as x is equal to minus resultant moment about y-axis over resultant force in the z direction. And this gives us distance in the x direction 2.13 meters. Similarly, y can be measured dividing the resultant moment about x-axis by the resultant force in the z direction, which yields the location of the resultant force in the y direction 4.5 meters. This example concludes here. Thanks for watching.